because of that, they have us put up just some of the things about Draper in terms of our relationship with AIA. And when we do AIA presentations, we stay kind of neutral on what we're talking about. So what you're going to hear from us right now is going to be, in general terms, what is LED and what is the structures and that type of thing. Right at the end, I'll mention what Draper is about as well. So we're going to be talking about several of these items on this list. Just real quick on my background, my name is Jim Hoodelbrink. I've been with Draper 31 years, so been there a bit. Draper is located in Spiceland, Indiana. It's a town of 800 people, and we employ about 750. So not everybody lives there, but we do pull from Indianapolis and surrounding areas as well. Draper's known for, on the AV side, projection screens, projector lifts, and video wall structures for LEDs and flat panels. So that's where our history comes from, and I am a product manager for Draper on the AV side. So I develop products, introduce them as we see good opportunities and new products coming out. So that's my background, and certainly I've had to learn a lot about LED in the past 10 years to make sure we can support the products adequately. We are going to go over a little bit of the definitions in general terms. Are very many of you very familiar with LED walls, direct view LED and stuff like that? Okay, so we have a few that some of this might be stuff you already know, but from an architectural standpoint, the reason why we're doing this is because a lot of times the architects may not know as well what's involved in getting an LED wall into a building. So we're going to go over some of the general terms. The pixel is really what you see here. If you get up close, you can see the crosshatch between these things, and that one little light diode is the pixel, and the subpixel of that is going to have red, green, and blue to create all the different colors. And when you need black, it just turns off. So it's going to be very versatile in how it creates the colors, and pixels are just a map of how many pixels do you need to change the resolution as well. So we're going to be talking about pixel pitch. That's the space between the center of the pixel to the next one, center of the next one. When you talk about that, that's really what you're talking about is resolution. LEDs, I already mentioned, are more like a light emitting diode. Direct view LED means they're directly printed on the circuit board. So you've seen televisions that are LED, but direct view LED is going to be right onto a board. And this is a very well aligned product, but the LED might only be this size. It's a very small thing that's going to go onto each board. OLED is the organic version of this, and LCD, you've seen a lot of those. Those are flat panels. That could be an OLED or an LED or LCD right behind us. In terms of its mounting location and what it does, it can be more of a typical display of what you're seeing. Nits is how we're going to use the measurement of light coming off of the product. And nits is important in terms of what we use for LED. I'm from the projection screen world and projectors, and we know nits, but we also talk about foot candles, foot lamberts, in terms of brightness coming off of a projection screen. So I know both of these things, and nits is definitely more important on the LED side. Contrast is also important, and that's where LED really can shine, because you can turn off the pixels, and that makes the blacks even better because there's nothing there. So and faceted displays are also some of the things we're going to talk about, which more are involved in the curved applications. We will get into the half-life of various products, so you know how long do these things really last in terms of the various different product items out there compared to LED as well. And then the LED module compared to the LED cabinet, we'll show better pictures of that here shortly. but one of them talks about these little squares that you apply on it, and then one of them talks about what product does it go on overall. So that's where the cabinet is. So as we get through this, some of the benefits of LED, when you're talking brightness, the best example I can give, if you've been to Las Vegas, and this is years ago when I went to the MGM, walked across the street, they had an LED wall, and it's old. It's been years. It was so bright even during the day. You sometimes couldn't even look at it. It was so bright. So LED can be extremely bright. You have control of that brightness, so you don't have to have it. But when you're in Vegas, when you're trying to see it during the day, yeah, you need that brightness. At night is when you probably saw it too, as it could have been too much. And LED is emissive. So what that means is it's coming straight off of the panel straight out, where other applications are sometimes transmitting through something, or they're being reflective, like projection. Projection's reflective. Lifespan of the products. These do vary because the manufacturers are trying to get better and better at this. But generally, laser projectors are going to be 20,000 hours on a half-life, 50,000 hours on an LCD product, and an LED product is going to be 80 to 100. So as you can see, the lifetime of an LED is going to be much longer for somebody putting that in. It's also very configurable. LED products, because of their size, allow you to do curves, allow you to even put it on the ceiling and wrap it around. You can do all kinds of different things. And in this particular sports book, they created the entire product to be a wall of it, and they can move images around and resize them. If they're done correctly, they look seamless. And that's an important part of this, and one of the things we'll talk about. That's not the case typically with flat panels, because as you put them together, you're going to see the lines of each flat panel. And they're going to be fairly efficient on power consumption. At Infocom this past year, we had two 8x16 walls in there, and we had to put in a lot of power. But what's interesting about LED is the power draw is based off your content. So whites are going to draw more power to the LED, but if you have a lot of contrast, a lot of blacks, the LED's off. So you can even control the power based off what content you want to put in. So LED can be more efficient on the power, and hence that can turn into a value to some degree. The value is also tied into the pixel sizes, because LED is tied to how many LEDs are in the wall. Each pixel roughly costs 4 cents a pixel, and that's continually going down. And that's why even 5 years ago, putting an LED wall into a conference room, it wasn't ideal, it was costly. But as they drive the cost down, now a lot of LED walls are similar in price to projection in a room like this. So it depends on what you want to do. Or it could be an LCD panel wall as well, which would be less money, but then you have the seams. So the options are growing with the value of the LED walls coming down in price too. The construction of it, excuse me, that's where it gets a little tricky. But for the most part, once the product is in, it's solid. And the key part is understanding the construction needs of an LED display, getting the right installers, getting tied in with the right companies, and getting it part of the building is where that usually has to be, whether it's indoor or outdoor. So the LED is a light emitting block, and what we're trying to show here is the understanding that there's going to be a module that is an individual block. And again, it's very hard to see here because this is a great install. But each one of these blocks are tiny, and there's several of these blocks in each one of those cabinets. So how you're making up that situation is understanding where the resolution is going to be. You know, what does your resolution need to be to properly present in the room or properly see the image? You know, the earlier image where I had it wrapping around in a casino that was wrapped around a column, that was used for digital signage. That resolution didn't have to be so tight. So the cost was lower because you had less LEDs. But understanding the cabinet sizes and the opportunities allows you to configure it properly and get the sizes that you need as well. So panels and cabinets, just as I mentioned, that's where the difference is. This shows it better. That's just one of the panels that are tied to the full cabinet. Okay, and the cabinets are what are important in the installation side of it. The LED module is also called the pixel card. You might hear it called that. Those are put in last. Those are what is finally put in on the final step of getting everything aligned. And most of them are going to be 2 to 8 modules. That fluctuates because some of the modules or cabinets are starting to get larger and in different shapes to support different applications and sizes. So even as we create this presentation for an AIA, we have to go into it yearly because there are that many different advances as you go forward. So the module sizes can change, and the pixel resolution and the size of those individual panels can change too. Applications, this is just going to be a quick run through of just showing some different photos of excuse me, of installs. The first one is more of a light signage above retail applications. They can have movement going on everywhere. I think that's Rihanna's new store that opened up a few years back. Hospitality applications, very popular corporate applications, this type of room, even in conference rooms and stuff like that. Houses of worship, as price points change, LEDs are going to grow because it does have a lot of positives. Government DoD applications, anywhere you need a control room application, that's almost pretty much the standard nowadays because of its flexibility and how little space it takes up. And in education, so they can go into varying sizes and opportunities for review. Resolution is going to play a part because pixels are by how many pixels. The price point is how many pixels are in the unit. When you get into higher resolution is where you're going to start to see that price still be higher. And as they continue to change, they'll get into applications like this. Broadcast production is one that's going to be one of the last because the resolution has to be so good in producing items like that. But they're already doing some of that now. So the pixels are getting that bunched up and tight that they can do that. And home cinema. So that'll continue to grow too, and opens up a lot of opportunities for even outdoor use. Now, display placement, that is kind of an interesting thing because it all depends on what you have to go into. LEDs do require a supporting system, and the supporting system has to be solid enough that it isn't going to change. It can't really shake that much if you say you have a garage above the floor and cars are coming across it. Is it going to shake something in the wall? The structure's got to be solid enough that it doesn't do that. And making sure those applications are taken care of is important. But it can handle anything that's going to be involved just as long as you let the designers know up front what the applications are. It can be mounted everywhere. And again, that depends on what we're going into. So standard wall mounts are are really done well. There's a lot of different mounting solutions there, and they generally go in pretty easily. But they can be ceiling supported from the floor, curved. Seismic calcs can be tied into it, so they know structurally what you have to be involved in for the walls. All of that can be considered in the process at the time of building. Wall structures are important. Excuse me. Wall structures are important because what you're going to have is you can't necessarily go into metal stud work and expect a 500-pound wall to be supported. So you'll have to make sure you have adjustments made in certain situations to support the wall. I don't know right off the top of my head on this particular wall how much it weighed, but it's a big enough wall. It's probably 400 or 500 pounds. So it's spread over a certain area, but there are PE stamps that can tell us how much it's going to take. So at the time design on the structure of the wall, they're going to know the weight of the whole metal work in the LED, and that needs to be passed on to the structural people for the buildings. So that's important to always keep a part of it. Likewise, standing structures, LEDs can look like a floor supported system, could look like a giant cart, depending on what you're after. And that's just a matter of then understanding where the floor is and how much can the floor support. Are you going into concrete or is there a subfloor? A lot of subfloors may need this product to go down to the concrete under the subfloor. So those are situations that we just would need to know up front. But you can do a lot of different things with it and curve structures. This is an OLED product where you can actually curve the panels and make a unique display. You can also do different things with the LEDs in terms of this, what we call a faceted smooth curve. So the LED is actually bent as well. The direct view LED panel is bent. Those get pretty unique in their application. And then faceted, I'm not particularly fond of the curve or the picture in this one because it looks like a flat wall, but there are actually flat panels, and then each one is bent to create the curve. So it just is a faceted system. And that's typically what you see because the LED manufacturers don't have to create a special curve and a special degree of curve to match what the application is. If you want that, there's a lot of them that can do it. It just means additional costs. Even ceiling suspended applications can happen. Structure wise, they get heavier. You got to make sure they're supported properly, and then it's just a matter of making sure you're working through it with the right people. And the required elements that get involved in it are tied more in the LED structure of the elements, which means what goes behind it, how much wiring is involved, where's the power typically come in. A lot of the power for LED comes in from above and handles a column. So that's not always the case, but a lot of the LEDs early on, you'd have a power for one panel row, which may light up. Maybe there's 8 panels here, 8, 8, 8. Then the power is going to light up this whole column area for one area. And then, so the power run could be fairly heavy. That could be 120 amp circuit. And so you could have multiples, but as this market grows, the power consumption is also lowering. So it's harder for me to tell you exactly what it is. I do know what we showed at Infocom, and we had 6 20 amp circuits for a 16 by 8 wall.
That's what this is. There's 6 20 amp circuits.
Okay. Yeah.
Well, overhead on each column. So.
Yes. But like I said, you could control that based off of content too. And you're not running a lot of white all the time. So the power, that covers the full power. And the reality is you may be using a half, a quarter, even a third of what that power really is, depending on what your content is and how often you use it. Surface types can be important to understand, but the manufacturers the manufacturers of the mounting solutions and the LED shouldn't be doing a lot of cutting at the location of the install. By the time it gets there, the project management should have all of that under control. Obviously, you're going to have some of it come up that maybe was unforeseen, where that needs to be taken care of. But most of the time, it's like a tinker toy set and a wiring set. You're doing a ton of wiring. You're doing a ton of anchoring onto the wall and putting up the structure and balancing it. Because all of these products are high precision. If you can imagine getting a seamless wall like this, your tolerance level has to be extremely tight. 1/10 of an LED pixel is a typical tolerance. Not always the same tolerance levels of what you have to work with, but it's about understanding how to get there.
We also have one on the second and third floor.
Football time.
We also have one on the second and third floor.
If you can imagine the precision of this, the pixel differences are tiny, and if the LED manufacturer is off even a little bit, as you put these cabinets together, you'll see those differences grow. And as the manufacturer of the mounting solution, same issue can happen. If you're not matching what that LED is, then you're going to have problems getting it lined up as the product grows too. So adjustability in the mounting solution is key. Do the mounting solutions have enough adjustability in the X and Y and the Z axis? X is the horizontal, the Y axis is the vertical, and the Z is the front to back. So having that adjustability throughout the product or the structure is going to be key. And that's going to make sure at this point you already know you can handle the weight of the wall, but how do you get that flat? And typically you say this is the installer's problem. Well, that's true, but if the installer doesn't get it dialed in, then you're stuck with a wall that has some seams that you're going to see. So making sure the wall is flat is key. And I jumped ahead on the slide there. But also having the precision pieces to get the cabinets flat and the modules flat before they ever go up. You know, that last step of actually putting that LED on here should just be put the LED on and you're done. All the alignment happens in the structure and in the cabinets before you put it up. Practically everything is modular. Practically everything is a column. So you're working in a column structure, but again, the cabinets are still rectangles that you're stacking on top of each other as you move forward. Corrosion and prevention, it depends on where you're going. Like we have a powder coating system that works for outdoor powder coating applications, but there's indoor powder coating. There's also systems that where you don't even need to paint the metal work on the back. Maybe you just need a perimeter trim around the edge to finish it out. So the metal work, if it's inside, may not have to have it. Just other than making sure it's corrosion prevented. And there's always a logistical issue. Do the components, can they get in the building? Can you get the components to move logistically through the doors that you have? That's something that you got to work with the project management on to make sure it happens, because some structures get really big. So they have to break apart. And then the trim out is where you get the proper finishes to go. And cooling's not a major issue because most of the heat from an LED comes off the front. But there is going to be still some heat on the back. And if it's a large enough wall, we'll put vented trimming on it too to help get that to cool down. Cable runs, power are also have to be put in place before the cabinets actually get hung. Structure gets generally put on a base structure, and then you get into the heavy duty part of making sure the cable runs are there. Now, this picture looks a little deceiving. You're running Cat 6 cable to a couple locations on an LED wall, but each LED cabinet connects together. So it doesn't have to look like that. It's typically more like this. So there's not a ton of cable behind there, but there certainly is going to have to be connection points that are carried out through the whole thing. And making sure the processing and cables are working properly is a key part of it as you get through it. Now, when we talk about installation, there are a lot of parameters. I've kind of touched on them, but specifying the LED structures is just an understanding of what the application is. If you're doing a flat wall, does your mount have enough adjustment left, right, up, and down to cover the entire wall? Because most installs are going to start lower left, lower right, and then you build the wall out as you go. And if it's an unflat wall, if you have to do a lot of adjustments or the installer doesn't start accurately in that first corner, they could run out of adjustments at the end. And so it's always important to know what we're getting into. Flat walls are much more well-known type of item where it gets really into the custom, and then you get really awesome teams that understand it better is when you get into those faceted video walls that have to be curved or they have to be floor supported. Then it's very important to know from a project management standpoint what you're getting into. And that's where those trained install techs come into play. In the final alignment, like this picture, you're seeing the back end before the LEDs are put on. That's where all the alignment occurs. So when the actual piece, the pixel piece goes on, it's done. Those cabinets are aligned already. I'd love to say that's how it always happens, but as soon as you put them up, then you know really what you got, and then you're going to have some of that final touch up to do it. And these are some of the things that you can run into. You'll see light gaps. You'll see situations like that. And to go into pixel pitch a little bit more, this is only an example of one pixel. This is not how every pixel distance is, but in this particular case, this example, the pixel pitch is 1.2 millimeters. So that's the space between the center of one pixel to the next. And then the actual pixel size is 1 millimeter. And then when you get into the space between them, it's generally, in this case, 0.2 millimeters. So that's where that center to center comes into play, what the gap is. And why that's important to the mount manufacturers is to understand what's your match point. Because now you know if we bring one cabinet next to the other, we have 0.2 millimeter matchup. So we are trying to get that tight on that matchup to be seamless as you look at this wall. And that can be difficult. And like the LED manufacturers, the mount manufacturers have to have a very tight tolerance. So that's where that X, Y, and Z axis adjustment are very important. Yeah, the example in this one of a tolerance level of 0.12 is the thickness of a piece of paper. So that's what your target is when you're trying to put an LED wall together. The goal is that's where it's going to get nice and clean and the finish is good. And the trickiest part is there is a very slight expansion to LED walls as they heat up. So you also have to take that into consideration for the flatness overall. You are doing a tightness fit, but the LEDs, once they heat up, will have a very small amount of expansion. Over a big wall, that can be a tougher tie-in. And these are examples of what you're trying to avoid. That one looks like it just needs some Z-axis adjustment. But do you have every manufacturer of mounts has some type of of different minute changes. And in this particular case, there's a set screw on the back of a cabinet that allows you to get to that point of adjusting that Z-axis front and back on a particular corner. But they usually have it all the way around. So when you're mounting those cabinets again, you're doing that adjustment and looking at this alignment throughout the process. So in this case, the whole bottom row is going up. And you're trying to align that bottom row, and then you're going to stack on top of it. And faceted means you're also putting that slight curve into it in each panel. And that's what I was trying to describe earlier. LEDs are flat panels. So if you create that curve, you're doing it with two flat panels at an angle. And that's what the mount manufacturers are trying to solve for. That gap does change depending on the angle. What you have to understand is you're bringing those two panels together at the angle. It's not the same as the 0.2 millimeter gap when it was a flat wall. So you actually get a little opportunity to spread to make sure the LEDs still match up and look correct. But at the same time, you have to be careful about light from behind the unit as well in those situations. The ones that can be tough before you light it up are the ones where you're perfectly balanced front to back and left to right, horizontal or vertically. But then you have to look at these pixels and are they off balance as they run across? If you do, then when you light up the image, then you're going to see that image jump. And so across the whole module range, you got to make sure those are perfectly matched up. We don't make, I make it sound like it's an impossible process. This has been around long enough. There's a lot of installers that really know their thing and really know how to do this well. So the key part is making sure you're just tied in with the right people that have the knowledge to do it. Folks like right here where we're here today. ADA placement for LED is on everybody's mind. You got to meet those standards throughout the United States. The typical ADA requirements are, the walls can't come out 4 inches. If they come out more than that, they're going to be a hazard. If the main or easiest way around that is to add some extra pieces down below. Even if the wall starts right here and it's going to be in that ADA area, there's no reason you couldn't put a facade or something down here to be more decorative. And then ADA's met, that they're going to know then that there's something there. Same from above. It's within that dotted red line where you have the issues. So there are ways around it, but most of the LEDs, a lot of them won't stick out 4 inches anyway. So it's usually not an issue unless we're talking about a rather larger application type of situation. And you can even inset them in the wall if you need to. So that gets pretty straightforward. From the standpoint here, is there any questions I can answer for anybody?